You can also find the linear factors of a polynomial if you know the zeros of the polynomial. The factor theorem describes the relationship between the linear factors of a polynomial and the zeros of a polynomial. Take note. Factor theorem. The expression x minus a is a factor of a polynomial if and only if the value a is a zero of the related polynomial function. Problem 3. Writing a polynomial function from its zeros. Part A. What is a cubic polynomial function in standard form with zeros -2, 2, and 3? Well, first we note that -2, 2, and 3 are zeros, so we can begin to write the function. f of x equals the product of three binomials, each one of the binomials the result of an individual zero. First, x plus 2. That binomial, by the zero product property, guarantees us that -2 is a zero. Next, the binomial x minus 2, which guarantees that 2 is a zero. And finally, the binomial x minus 3, guaranteeing our third zero, 3. Then we'll multiply these binomials in order to write our polynomial function in standard form. The order in which we multiply binomials doesn't matter. In this case, looks as though we'll be multiplying x minus 2 and x minus 3 first, and then using the distributive property, and finally simplifying to write that f of x equals x cubed minus 3x squared minus 4x plus 12. And we can state that our function f of x has zeros -2, 2, and 3. Part B. What is a quartic polynomial function in standard form with zeros -2, -2, 2, and 3? Well, again, we note the zeros, and we construct binomials based upon those zeros. First, the binomial x plus 2. Note when we substitute -2 for x, we get a 0. Next, the same binomial repeated, x plus 2. That's because our 0, -2, was listed twice. Next, the binomial x minus 2, related to a 0 of 2. When 2 is substituted for x, we get a 0. And finally, x minus 3, the binomial that when 3 is substituted leads to another 0. Then we multiply and simplify, writing in standard form, and state that the quartic polynomial g of x equals x to the fourth minus x to the third minus 10x squared plus 4x plus 24 has zeros -2, -2, 2, and 3. Part C. The instructions say, graph both functions. How do the graphs differ? How are they similar? Well, note the graphs. On the left, the graph of f of x from part A, and on the right, the graph of g of x from part B. Both graphs have x-intercepts at -2, 2, and 3. The cubic has down and up end behavior. The quartic has up and up end behavior. The cubic function has two turning points, and it crosses the x-axis at -2. The quartic function touches the x-axis at -2, but does not cross it. The quartic function has three turning points. Your turn, part A. What is a quadratic polynomial function with zeros 3 and -3? Part B. What is a cubic polynomial function with zeros 3, 3, and -3? And part C, a reasoning item, graph both functions. How do the graphs differ, and how are they similar?